Hello and welcome to Chapter 7. This week we're going to be covering memory. What is memory? Memory is the nervous system's capacity to retain and retrieve skills and knowledge. We have multiple memory systems, and each memory system has its own rules. Memory involves processing information. The information processing model compares the working of memory to the actions of a computer. Memory operates over time in phases. There's encoding, storage, consolidation, and retrieval. Encoding is the processing of information so that it can be stored. Storage is the retention of encoded representations over time. Consolidation is the neural process by which encoded information becomes stored in memory. And retrieval is the act of recalling or remembering stored information when it is needed. Reconsolidation of memories. Reconsolidation is a neural process involved when memories are recalled and then stored again for retrieval. To understand how reconsolidation works, think of it like this. A librarian returns a book to a shelf for storage so that it can be taken out again later. The funny thing about reconsolidation is while the memory is pulled out of memory, it is no longer there. You have the chance to modify it before you put it back into permanent memory. Here's a handy graphic from the book that explains what I'm talking about here. According to the traditional views of memory, we gain information from experience. That information is encoded and then stored for retrieval. Each time it is retrieved, the information remains the same as it was during the original experience. The idea of reconsolidation complicates these traditional views, however. According to this idea, memories can change each time they are retrieved. Each memory is of the previous retrieval, not of the original experience. Memory is the result of brain activity. In Hebb's interpretation, memories are stored in multiple regions of the brain, and they are linked through memory circuits. Multiple brain regions have been implicated in memory, and this includes the hippocampus, prefrontal cortex, temporal lobes, cerebellum, the amygdala, and the brain structures involved in perception. Memory involves long-term potentiation. This is the strengthening of a synaptic connection, making the postsynaptic neurons more easily activated by presynaptic neurons. The word potentiate means to strengthen, to make something more potent. The finding that the NMDA glutamate receptor is involved in long-term potentiation led researchers to examine genetic processes that might influence memory. Only for large amounts of glutamate increases numbers of receptors on postsynaptic neurons and more synapses per neuron. Memories results from these strengthened synapses. The epigenetics of memory. Epigenetic mechanisms control how DNA is expressed. One such epigenetic mechanism involves a class of enzymes called HDAC, which inhibit gene expression. There is emerging evidence that blocking HDAC leads to increased memory. It operates as a brake for creating memories. There's a possible treatment for Alzheimer's here. Memory is distributed throughout the brain. Lashley's term engram refers to the physical site of memory storage, the place where memory lives. Equipotentiality is the idea that memory is distributed throughout the brain rather than confined to any specific location. All right, here's a graphic again of the brain. These are the brain regions associated with memory. Prefrontal cortex deals with working memory. The hippocampus deals with spatial memory. The temporal lobes deal with declarative memory. Cerebellum is motor action learning and memory, and the amygdala is fear learning. The amygdala is involved in memory in the sense that if you learn that something can hurt you, you will then fear it. Do you fear a spider innately, or is it because you have experience with spiders? The case of HM. In 1953, doctors took a radical surgical approach to quiet the seizures of Henry Molaison, aka HM. Sadly and unexpectedly, the surgery caused HM to lose the ability to remember new information over long periods of time. Over the course of 40 years, HM participated in countless experiments and became one of the most famous people in memory research. They managed to teach him some motor skills, but he did not remember learning them. Some parts of his memory system still work, though. This is a drawing of HM's brain. The portions of the medial temporal lobe that were removed from HM's brain are indicated by the shaded regions. Shows that they were removing quite a bit of his brain. Here's a picture of Henry. Known to the world only by his initials, he became one of the most famous people in memory research by participating in countless experiments. This is a case study, by the way, and judging by the looks of it, Henry doesn't seem unhappy. Regions for memory. Memory involves multiple regions of the brain, but not all brain regions are equally involved. A great deal of neural specialization occurs. The take-home message here is that memory is distributed among different brain regions. Memory does not live in one part of the brain. The middle section of the temporal lobes, called the medial temporal lobes, is responsible for the formation of new memories. The actual storage occurs in the particular brain regions engaged during the perception, processing, and analysis of the material being learned. Here's a graphic from the book to show what I'm talking about. These 4 horizontally sliced brain images were acquired using magnetic resonance imaging, or MRI. In each pair, the top image shows the brain areas that were activated during a particular sensory-specific perception. The bottom image shows the regions of the sensory cortex that are activated when that sensory-specific information is remembered. Notice that the perceptions and the memories involve similar cortical areas. And that concludes Part 1 of Chapter 7, Learning.